Yay, it worked. Hey everyone, my name is Fraser Cain. I'm a publisher of Universe Today, and this is your weekly space hangout for Friday, April 25th, 2014. And joining us this week, we've got Brian Coberline.
Hi.
We got David Dickinson. Hey, David.
Hey, it's crappy internet, as always.
As always. Got Jason Major.
Hey, not much better internet here. Yeah.
We got Morgan Renberg. Hey, Morgan.
Hey, Fraser.
And Nicole. Dr. Nicole Gallucci, also known as Hangoutathon.
Hi, everyone. I am here to do a brief plug for the Hangoutathon that is starting in 20-something hours, I think 20 hours from now. I'm in Pamela's attic, Pamela's attic right now. We are setting up the schedule, the set, the props, all the fun things. That's why I'm wearing these silly things. They respond to supposedly respond to brainwave activity, and so we're gonna hopefully be including these soon in our guerrilla science outreach efforts, so we can have people wearing funny ears and seeing what they do while they're mapping craters.
So just over the course of the Hangoutathon, as they start to droop down.
Exactly, they're just gonna be like
the brain activity approaches zero. Okay, so what is the Hangoutathon, Nicole? So people don't know what's going on. What's the? I almost called you Pamela.
I know.
You're a distinct person from Pamela. I know it.
Nobody's done that in a while. Jeez.
No, I know.
So the Hangoutathon is a fundraiser event. It's actually kicking off a 36-day fundraiser that we're doing for CosmoQuest. We're starting with a 36-hour-long Google Hangout on air. We will be celebrating science education. We'll be showcasing projects that people are doing all over the world with astronomy and science education. We'll also be throwing in some fun, silly game aspects too. We'll have some really creative art stuff. We'll have a virtual star party. We're just going to have it all. So you can go to the CosmoQuest Google Plus page where there is a link. We're also putting out countdown tweets every hour, so you can find the donate page and the page where you can watch the Hangout. And I will give you see if I can give you a brief look. Here's the attic as it's coming together. Oh, you guys are going to get dizzy. This isn't working.
Oh, I should have brought you my
Vertigo kicking in.
There we go. There's people and set and things and the tiny intern behind me. So, yeah, we are currently getting everything finalized for this big event. So we hope you can join and watch and share the link, mark craters, do all the fun stuff. We really hope you enjoy and get a kick out of it.
And everything gets going at 8 a.m. Pacific on Google Plus and on CosmoQuest, and we'll post a link on Universe Today, and it's going to start at 8, and so that's 10 o'clock Central, 11 Eastern, 11 Eastern, and then 4 p.m. British time. So even the Australians, 1 in the morning. So.
We have people from around the world joining us, and we'll be doing the social media feeds as well. So it'll be a pretty big event, and this is all to raise money to make a more scientific future for all of us.
That's awesome. Well, we're as part of the CosmoQuest umbrella, we're glad to help out. All right, now, did you want to stick around and mention any stories, or do you want to book out?
No, there are way too many people in this room who are keeping quiet just for this, so I'm going to sign out and continue working on setup. So thanks for letting me do the plug.
All right. Can't wait. See you later, Nicole.
See you later.
All right. So stories. I forgot to mention the stories. So we're going to talk about the EVA that happened. And an update on what happened with SpaceX, because last week we broadcast the SpaceX launch. Hey, and guess what? Guess who got a copyright takedown request? Within a day, I got a copyright violation because I was posting a stream from NASA television.
Cool, that's the lost episode now. So.
Yeah, it is. Well, no.
Who was it? Who issued
it said it said CDS Mail, MALE. So, so I think people think that CDS means for the
menswear catalog.
I don't know. No, it stands for like content detection service or copyright detection service or something like that. Why it said mail, I have no idea. But anyway, apparently someone out there somewhere owns
Because
NASA
you're a
television.
man and you put up a streaming NASA
Right,
video.
right, of course. Yeah, that's it. So anyway,
That's weird
whatever you
because
do.
we embed those launches on our websites all the time. So.
Yeah. So Google, we really appreciate you defending other people's ownership of NASA television. That's we think that's right, and as opposed to recognizing that NASA releases it license free to the universe and anyone can use it for anything they want, including bringing it into the Weekly Space Hangout. So we're gonna give a sort of an update on Cosmos, which we've all been watching except for me. We're going to talk about asteroids. Maybe are going to hit Earth more often. Maybe not going to hit Earth more often. We're going to have a bit of a fight going on.
More often, that's a relative term. So.
But devastating
It's a conspiracy.
asteroids cripple the planet on a regular basis, or not ever. So somewhere in between. And we're going to talk to. We're going to have some interesting observational stuff. So. Let's get cracking. Morgan, why don't we start with the sort of the things that happened in human spaceflight over this last week?
Yeah. So going back maybe about a week and a half now, there was routine testing of computer systems on the International Space Station, and they do this every once in a while just to make sure that everything's working all right. And this last test revealed that one of the computers, a backup computer, called an MDM, was malfunctioning. And an MDM stands for a multiplexer and demultiplexer. And this is basically a technique of taking a bunch of communication streams, signals, and combining them into one very efficient signal to send back to the Earth. And you can imagine this is important for communicating all the data back and forth to the space station from hundreds of miles above the surface. Unfortunately, this is the only computer on the space station that isn't in the space station. It was bolted to the outside of the space station. And so they did some tests. They determined that they couldn't just let this thing sit there broken. And they sent out astronauts, basically, to go out earlier this week on Tuesday and fix this computer, replace it with a backup that they had stored on board. And normally this would be no big deal. But you might remember that over the last year or so, NASA's had a number of issues with spacewalks and spacesuits, from filling up with water in the helmets to getting heating problems with some of the external heaters. And so they had actually basically sworn off of spacewalks that weren't for emergencies. And so they had to classify this basically as an emergency, and they sent out a pair of American astronauts to replace this earlier this week, and it went off completely without a hitch. It was, in fact, the shortest successful spaceflight in the history of the International Space Station. I'm sorry, spacewalk in this history of the ISS at just over an hour and a half. And they went out there, they took off the old computer, they bolted on the new computer, and got back in, no problems. And this included the use of a brand new spacesuit that had just been flown up, last Friday, a week ago today, on the new Dragon capsule. And so they were able to put that into service and use one of the other spacesuits that they thought was working well, and they had no problems at all.
That's amazing that they used one of the new spacesuits and put into a spacewalk right away.
Yeah, so they included all of those safety mechanisms that they'd been developing over the last year, like the straw snorkel and the water-absorbent pads and all of that stuff. So that was all included just in case. But as far as NASA has made publicly available, none of the astronauts encountered any unusual problems with their equipment while working on this.
That's amazing. And so what happened with the SpaceX launch? Now, as I mentioned, we, of course, got in trouble with international copyright law by broadcasting the launch. What happened?
Yeah, so it basically went off without a hitch. So the launch happened, it boosted the Dragon up to the space station, and that docked normally as expected. And then what was new this time is that they bolted landing legs onto the Falcon 9, the actual rocket that launches the Dragon. And as it fell back to Earth, they extended these legs and restarted the engine. And they used this engine basically to safely power the rocket back down to Earth, rather than just letting it plunk down into the ocean. And so they were able to controlled fly the rocket back to the surface of the ocean, where it hovered for 8 seconds before it was taken out by a wave. And there were like 15 to 20 foot seas at the time that they were doing this test. And so it wasn't going to survive that. But it went down, it hovered for 8 seconds right above the surface of the water before getting whacked by a wave. and they'd only sort of expected...
Anyone get video of this?
I was going to say, we never get video,
Well,
did we?
so Elon Musk, the CEO of SpaceX, held a kind of a surprise press conference this afternoon where he announced that it worked. And he says that they have very weak video of this, and they're cleaning it up and they're going to post it online sometime soon. And they're hoping that other people out in the community can basically make it look like something. Because the seas were so bad, they said they couldn't even get the Coast Guard to go out there to get the ship, or to get the rocket. So they didn't have their support ships where they expected to have them. The signal was very weak. So they had telemetry, but very weak video. But we should hopefully be seeing something soon. And because this worked a lot better than they expected, they only gave it about a 30 to 40% chance that they'd be able to pull this off. They're pretty confident now that after several more tests in the ocean later this year, they'll be able to try to land one of these guys on land at Cape Canaveral by the end of the year. And this is just a huge deal because the Falcon 9 is already the cheapest available rocket in its class, and it costs about $60 million to fly it once. Of that, only 0.3% is the cost of the fuel. That's less than $200,000. The rest of it is a one-off, $59.8 billion rocket that just falls into the ocean. And this part that they were able to land over the Atlantic last Friday was about 70% the cost of that. So if they can land that back on land and reuse it, they can reduce the costs by a factor of more than 2. And
I'm a little amazed that the Falcon, I mean, I'm sure they've worked out the math of this, but I mean, it's going up and starting to push that cargo out across the Atlantic Ocean. And so then for it to return back to Cape Canaveral, it's going to have to turn itself around and thrust in the opposite direction to kind of slow its horizontal velocity and bring itself back. If I was designing this in Kerbal Space Program, there's no way I would build this rocket, but if it could, take off and then fly over the Atlantic a bit and then maybe come down on some floating platform or something, that might be a way to kind of, close the loop on this. But anyway, if it can make it come back to Cape Canaveral, I'm impressed.
Yeah, so the Falcon 9 is a 2-stage rocket, and they're only trying to bring the first stage back right now, and that's the stage that'll stay more close to the coast. And they also point out that different missions require, different trajectories. And the ISS requires them to go further out over the Atlantic than a typical commercial spaceflight does, where you just want to get it up into orbit. Because, the ISS, they're basically chasing it down with the Dragon, so they boost it out in front of the ISS so it can catch up to it. But for other ones, it'll launch much closer to the coast and never really stray as far.
Yeah, I mean, you can see them launching from, say, California and then landing somewhere in the middle of the U.S. once they've finished their, that initial flight boost. But anyway, I don't know the exact re-entry characteristics.
I wonder what kind of clearance they're going to have to get to fly that back. I mean, they must have to retain the remote detonate capability because,
right.
So it doesn't hit a building or a person or anything when it flies back.
So they said they've been working closely with the Air Force, who operates many of the facilities down at Cape Canaveral, and they've selected several areas that they think that the Air Force believes are good targets for landing on land. And Musk mentioned that they probably need to get accuracy down to only about within a mile or so before the Air Force will greenlight them to land it. So these are areas, not in the middle of cities and things like that.
Yeah.
So this is all really good news, but he did have a little bit of, less exciting news to mention as well, which is that SpaceX is turning around and suing the Air Force for all this help, and they're going to turn around and sue them.
How not to make friends with
I can say that was unexpected.
Right, and so I mean they have what appears from the outside to be a legitimate complaint, which is that the Air Force, the Department of Defense, and the U.S. government at large has awarded a very substantial launch contract of more than 30 launches to the United Launch Alliance, which is a conglomerate made up of Boeing and Lockheed Martin, without any sort of bidding process. They gave them the contract without allowing anybody else to compete. And SpaceX argues not only is this bad for space business, it's hurting competition, not letting them basically have a fair shot in the market, but it's bad for the American taxpayer as well, because the Atlas V, which is the closest competitor to the Falcon 9, costs almost 4 times as much to launch. It's, about $400 million compared to what SpaceX expects will be about $100 million to launch a military Falcon 9. And Musk also points out, maybe more on a personal note, that the Atlas V contains many critical components that are manufactured in Russia. And he thinks and the SpaceX says that, with the U.S.'s current stance towards involvement with Russia, doesn't make sense for our critical launch capabilities to be reliant on parts made in Russia. And so they filed suit against the Air Force, asking them to basically cancel that contract, open up the process again. And sort of the money quote he says is, if we compete and lose, that's okay. We just want the chance to compete. That was basically the sentiment that he said. He's, maybe they have a better product than we do right now, but we need to be given the chance.
That's deadly. That's good.
Why would they give ULA the contract? They're Boeing and Lockheed Martin. Who makes all the stuff for the Air Force? Boeing and Lockheed.
Yeah, exactly. All of the fighter aircraft. Absolutely. Okay, well, let's move on. So now we're gonna have the big fight. Jason versus Brian.
Oh my God, check it off.
So Jason, why don't you set this up and you tell us why asteroids are a terrible threat and we better get cracking on finding every single one of them.
Well, duh. I mean, they're just space rocks that have Earth's name written all over them. Every single one of them wants to destroy us and our homes and our pets and our families. All right. So background information. When you think about big recent asteroid impacts on Earth, there's a few key events that come to mind. One of them would be the 1908 Tunguska explosion that flattened hundreds and hundreds of acres of forest land out in Siberia. And that was witnessed by, more or less directly witnessed by a few people. And then there is the 2013 February impact that happened over Chelyabinsk, again in Russia. Russia's a big country, 6.6 million square miles, so I mean there's a lot of room for asteroids to come flying into. But there's actually been a lot more decent-sized impacts that have happened over remote locations on the planet that we didn't really know about because they weren't witnessed by anybody. But they did happen to be picked up by a nuclear weapons test network that's able to basically see what's going on around the planet if anybody's testing out some nukes and stuff. So those explosions get picked up. So oddly enough, since 2000, there have been, including the Chelyabinsk event, there have been 26 impacts, or I shouldn't say impacts, but explosions that have happened around the planet that were over a kiloton in energy output, some of them up to 600 kilotons. And these have happened over the ocean. They've happened over Antarctica, over the South Pacific, places where there wasn't somebody with a dash cam to pick it up and put it all over the internet the next day. So what happened was on Earth Day, the founder, Ed Lu of the B612 Foundation, he's also was a shuttle astronaut, and fellow shuttle astronaut Tom Jones, and Apollo 8 astronaut Bill Anders gave a presentation at the Seattle Museum of Flight, and they were showing a visualization of all of these 26 impacts that have happened that nobody really knew about until the data came in from the nuclear test network. And the purpose of the B612 Foundation is ultimately to build the Sentinel spacecraft. Now, this is privately funded, and it's a spacecraft that will launch on a SpaceX rocket and go into like a Venus-like orbit around the sun, and it'll look outwards in infrared to hopefully spot, identify, and track near-Earth asteroids that are over 40 meters in size. So these are things that, as Ed Lu likes to say, are city killer asteroids, and that, the only reason we haven't been hit by one so far is just blind luck, and that's Ed's quote there. But you can see where he's trying to basically get people excited about what Sentinel can do, and to keep up the awareness that I mean these things are out there, and occasionally they do hit our planet, and the danger is you don't want something like that impacting the atmosphere over a heavily populated area, a major city, because the damage, they can cause a lot of damage, as was seen in Chelyabinsk last year. Over 1,200 people were sent to the hospital because of injuries from that air blast.
Yeah,
now,
the Chelyabinsk one was about 500 kilotons,
yes.
and so as you said, there was one that was 600 kilotons. So,
if I have a chart here now, I believe the 600 kiloton one. That may have been the Chelyabinsk one that got listed as that. So you're talking, over 500.
Yeah.
Chelyabinsk came at us from a sunward direction too. Is one of the reasons we didn't detect it beforehand, and Sentinel's going to cover that part of that blind spot. So.
Basically, what Sentinel is supposed to do is fill in that blind spot to identify the near-Earth asteroids that are of that smaller size range, that aren't the the big kilometer size ones. I mean, these are the 40-meter and up ones, the ones that are going to make it through layers of atmosphere to detonate at to either impact the surface or detonate at a low enough altitude to send down an air blast that can damage property and potentially injure people. Now I'm going to, before Brian jumps in and starts swinging at me, I will drop in the caveat that the information that this visualization presented is not new information. It has been out there for some of it up to 5 years. Now, obviously, not the impacts that have happened since before 2009, but the rate of impacts is surprisingly large, of this size, to some people, but not to everybody.
But I don't recall us ever getting a press release from the Nuclear Detonation Watch Agency saying, oh, and by the way, a 600 kiloton asteroid just hit yesterday somewhere over the Atlantic Ocean, just thought you should know. That is not. I have not been getting those press releases.
That is, and well, that's true. That's true. So this data visualization takes into consideration some of this stuff that a lot of us, me included, and Fraser and other people who write about these things on a daily basis, did not know about. So even though the data may have been there, even if it was only in model form, these are not modeled impacts. These are actual events that were picked up on this network.
So what you're saying, Jason, if I can really sort of boil this down, we are doomed, and we need the Sentinel mission right away. Okay.
Build it now, and launch it tomorrow.
Brian, why are we safe and Sentinel should never be built?
Okay, so I actually would say that Sentinel should be built.
Okay, but
or something similar. I mean, it's actually a very good program, because what it's doing is it's going to be put in an orbit near Venus, so it can actually look out at meteors coming in towards Earth. And that's the sunward side thing is actually a problem. When we look towards the sun, we can't see anything coming. So they're putting it in the Venus area so that they're always looking out.
Right, and then we'll be able to do all kinds of things about it.
Well, I mean, whether or not we can do something about it, we can get an accurate survey of them.
Right.
And that's not a bad thing. You know, and if you look at the video itself, they're very clear. Everything they say is absolutely true. The problem is that everybody hears not what they're saying, but what they think that they're saying. And so the whole idea where this hits the press, where there are vastly more meteors than we ever knew were going to hit, isn't true. We actually know the rates at which meteors hit, and this is in that range. So these impact data, some of which were already known, some of which weren't, but the rate at which they're happening is exactly what we would expect, given what we know meteor sizes are.
And that rate is fully acceptable. It's a risk we've been living with for centuries.
It's a risk we've been living with for centuries. I mean, part of what this says, actually, is how remote most of the Earth actually is. We think of, in this multi-connected, hyper-populated world, that we have everything everywhere, and we don't. Something that happens over the Pacific, we don't see at all. The other thing to keep in mind is that even though the number of impacts, 26 impacts sounds very big, but they're not 26 Chelyabinsk impacts. That was on the very large side. And the distribution of meteors is actually what we call log normal. And what that means is if you had a 1 meteor size, suppose you had 1,000 of those, you would only have 100 of 10 meters, only 1 of 100 meters. It's a logarithmic scale. So you're much more likely to have small impacts than big impacts.
Right.
Now,
So you're getting, more on the, what was the low end of it, Jason, was like 1 kiloton?
1 kiloton.
1 to 9 kilotons.
Right, and so the vast majority of that 26 is probably in the 1 to 9 kiloton range,
Exactly.
and those are a bright shooting star.
Exactly.
Now,
And that's
put math and statistics against, it's kind of like buying insurance. You hope that you will never get into that accident. But if you do, you want to be covered, or hopefully, even better, have some kind of procedure or plan that keeps those bad things from happening. And the truth of the matter is that some of these impacts, 4, 5, 6 of them, were what they would call Hiroshima-sized detonations. The energy output is in that 15 to 20 kiloton range. Now, they were happening high in the atmosphere. So the energy output wasn't hitting the ground like you would see in an atomic weapon. But still, the energy's there.
Right. The other thing I would add, though, is they're not distributing radiation. These are not radioactive.
Exactly.
Right.
I think a good analogy would be like a tornado warning system. Most people are not going to die in a tornado. Some people do. There is a risk. But most people won't. But having a warning system for something that unpredictable is a good thing.
Right, and I think one of these issues, right, is you build the Sentinel mission, you put it in this orbit, it can see all the stuff that we can't see from Earth, and you can map all of the objects down to within whatever the size is, the 40 meter, even smaller, and then you can run their orbits into the future, and you can know if in the next couple of 100 years there's anything that's going to cause us a big problem. And with one mission, you could pretty much map out the dangerous asteroids to a pretty high degree of accuracy for the near future, and that I think is totally worth doing. And I think that's why you said it's a valuable mission for a one-time expense. Let's get that mission up and let's map it all and just know, are we safe? And then maybe there is a big rock we're going to have to deal with in 30 years. Let's get on that.
Right. Exactly.
But don't panic about the asteroids.
The big thing, though, is that it's not more than we knew beforehand.
Yeah.
But it's funny. It's not more than we knew, but it's still surprising to a lot of people. I didn't know about a lot of that, and it was so that was kind of the takeaway I think from this, more so than they didn't know, but we do. I'll see where some news groups went that way.
And in terms of a scientific aspect, for people who are actually studying meteor impacts, there's been growing evidence that the amount of impacts are actually slightly higher than we had anticipated. So not 26 to 1, but that it's a few percent higher. And that's partly because we're getting more data. And so having a project like this that can give us even more data on even smaller rocks can help us refine what that parameter is. One of the things, the whole log distribution, one of the questions is, what is the exact slope of that log line? Because if it's steeper, we have more big ones. If it's shallower, we have more littler ones. And that's hard to figure out. We get, the major impacts. We get the ones that we can measure. But you kind of have to look at the statistical distribution to figure out where that line is. And there's some debate. So the more data we can get on the smaller rocks, the better we're going to be able to refine that distribution.
Yeah, that will even tell us the distribution of just asteroids in the solar system. Like that data, it's kind of surprising that data hasn't been made available to scientists with a level of transparency that it could. Hugo Burnham makes a great point. Is the arrogance of humanity that we cannot believe something has happened unless we saw it. It's ironic that we can thank nuclear weapons for understanding how many asteroid impacts there have been. What a great use of this program. If nobody had any nuclear weapons, then it would be great for detecting asteroid impacts and improving science.
Yeah, I'd like to address that, I guess, and address what you said too, and we can sort of tell a little story here. If you go back to the 1960s, we've implemented our first generation, basically, of these nuclear test ban search satellites. And you go back that far, and they used searches for gamma rays to find nuclear weapons. Nuclear explosions go off, they emit lots of gamma rays. it also turns out that supernovae emit a lot of gamma rays. And so the military, the Department of Defense, Russia, discovered gamma rays coming from space back in the 1960s. But it was decades before they told the scientific community about the existence of them, because they wanted to make sure that no classified information about our capability to detect Soviet weapons was released. So it could very well be, like you said, that we see all of these explosions and have for decades coming from meteors, but the military isn't comfortable sharing that information because it reveals where we're looking and how sensitive we are towards what we look at. And so while we're benefiting from the fact that we're looking for nuclear weapons, there's a long lag time before we really get the full scientific benefit of that.
There are things classified all the way back to World War I. I mean, a lot of things get just automatically classified without anybody ever looking at them. So that's one of the key problems they have.
All right, so let's move on then. So asteroids, maybe panic, maybe not. We'll move on. Let's build the beast. We can all agree. Let's build the Sentinel mission, B612. If you required our approval, you have it.
How much is that going to cost? Do they have an estimate for that?
I don't have actual numbers, but one of the comparisons that I keep seeing is it's about the price of a highway overpass. So
it's a couple of
it really
million,
seems like a
isn't it?
no-brainer.
Well, we can't manage to build those in this country either. So.
All right. Well, anyway, Brian, you have our approval.
Highway overpasses. So.
I think we can all agree. Go ahead, B612. You have the Weekly Space Hangouts approval. If you need that in writing, we will sign something. All right, let's move on to some observations we can do, Dave. And the big one is Saturn.
Yeah, Saturn is reaching opposition on May 10th, which means that is going to be opposite from the Sun. It's going to be rising in the east as the Sun's setting into the west, and it's going to be moving into the summertime sky. The Moon's going to be very near it about 4 days after opposition on May 14th, and it's going to actually occult Saturn, although we won't see that here from North America. We're just going to see a close pass. It's Australia and New Zealand are actually going to see an occultation. Saturn's being occulted by the Moon nearly every lunation, every time the Moon comes by it. Unfortunately, I was looking ahead for North America. Our best chance to see it is in August during the occultation. I can't remember the date, but it's in the daytime here, which I have seen Saturn near the Moon through a telescope in the daytime. It is possible. It's faint, but if you've got really good skies and really good viewing. One good thing about Saturn right now during this opposition is the rings are getting wider. If you remember watching Saturn back in 2009, we had the rings edge on to us, which is kind of neat to see too, because it's a view you only see that once every 18 years it comes back around. The rings are moving toward wider right now, which means from our vantage point, they're not really tipping, but what's happening is Saturn's moving in its orbit, kind of the same thing as like with the Earth having its seasons, where it's angled at a different angle from our perspective. So we'll see those rings. The widest it goes is a little over 25 degrees from our line of sight. This year it's an average of about 22, which is pretty good, and it lends for a lot of good photos where you can see the Cassini division, you got all the moons. There are 7 moons within range of a backyard telescope. Titan is one that you can catch even with a small telescope, and it's kind of cool to watch it change position. So Saturn is definitely going to be one of the highlights. We should be having it in the virtual star party here. We went from having no planets a few months ago to now we've got all the classical planets except for naked eye planets except for Venus. Matter of fact, in May, once Mercury reaches greatest elongation toward the end of May, we're going to have Mercury, Jupiter, Saturn, and Mars all in the evening sky, and Venus is the only holdout. Venus is spending most of 2014 in the morning sky. It's that bright thing in the morning sky right now.
It's really bright in the morning.
The moon is right next to it. I saw it this morning too. That was kind of cool that you had.
Yeah, I saw it too.
Paired off together.
I don't know why. I was up at like 5 in the morning, and there's a beautiful little crescent moon this morning.
There's also an annular eclipse on Tuesday that's going to occur. Only no one will probably see it because it occurs over a very small area in Antarctica. The annular phase of it. They will see partial phases, about 50% partiality over Australia and New Zealand. New Zealand just misses it. Australia sees it. Scattering of islands in South Indian Ocean, Tasmania sees it. There's some discussion right now about whether anyone is going to actually bother from any. There is a research station in Antarctica that ESA runs called Concordia that is very close to the annular path. Now I ran some simulations of it, and they would see the annular eclipse right sitting there on the horizon because they're going in. We're spring going into summer here. Down there, their fall going into winter, so they're starting to lose the sun. So the sun kind of skims the horizon if you've ever been down to those Arctic, Antarctic kind of latitudes down there. So I don't know if I pinged ESA to see if anybody is going to try to venture out on a snowcat or anything to try to actually catch this. I ran some simulations for there are some sun-observing satellites that sit in low orbit. ESA has their Proba 2 satellite, and there's the JAXA NASA high node satellite. I ran some simulations, and it is possible they might thread the eyelet of the annular eclipse. What this annular eclipse is, technically it's known as a annular non-central eclipse with one upper limit, meaning that the shadow, the antumbra, or the umbra of the moon during an annular eclipse called the antumbra, is just going to barely skim the surface of the Earth down there. It's just going to kind of nick it. So it's a very bizarre. This actually is one of the closest near-miss eclipses we have for this century. So it's a consequence of having the lunar eclipse that we had, the blood moon last week, that now we're going to have a solar eclipse paired with that. And we're going to have another pair in October as well, where there'll be a total lunar eclipse that North America will see. Then North America, the Western North America, is going to see, I believe it's a 50 to 60% partial eclipse, so solar eclipse.
Right. Yeah, they go solar, like it's lunar, solar, lunar, right? You get these combinations.
We had a discussion. There was somebody that commented that actually gave me a pretty engaging discussion about what is the minimum number of eclipses per year. And I checked with Michael Zeiler on Eclipse Maps and did some research into this. And yes, it is 4 eclipses, 2 solar and 2 lunar, but you can have only 2 solar if you discount those shallow penumbral lunar eclipses that those aren't really high interest items, because when the moon dips into the penumbra of the Earth, it's so subtle that a lot of people don't even bother to observe those.
Could you coin a name for that, please, David? Because
beyond a penumbral eclipse, yeah, we need something like blood moon.
No, but like a year with not a lot of eclipses, and then a year with a lot of eclipses. So eclipse, mega eclipse,
mini eclipse. Yeah,
anyway,
it's four. And FYI, just for interest, the maximum you can have in a calendar year is 7 eclipses total, lunar and solar. So
yeah, you'll be glad to know.
I combed through the entire 5.
In our most recent video, we were talking about why people go crazy during the full moon, and we mentioned the mini moon. So I'm trying to sort of push that.
I haven't seen that yet. I have to watch that.
Yeah, we just shot it yesterday, so we're still looking at another couple of weeks before that goes out. Spoiler alert, it's a myth. Okay. Let's move on. So now, Morgan, I think you were the only. Did anyone else watch the latest episode of Cosmos? Where are we at?
I saw it. It was pretty good.
Yeah, Morgan, what'd you think?
Yeah, I liked it. It was, this was the most focused I think they've been on one person since starting. This was basically the story of how accidental discoveries can have really profound effects on our day-to-day lives. And it followed the story of a young scientist named Claire Patterson. And he was tasked with measuring the age of the Earth, or estimating the age of the Earth. And you do that, and we still do that today, by basically looking at the ratio of uranium to uranium to lead. Because uranium is radioactive, and it decays over time, and eventually ends up as lead. And there's some amount of natural lead and some amount of natural uranium in the universe. And then as that ratio changes, you can basically see that as a ticking clock. And if you can measure those two numbers, then you can get an estimate of the age. And it's pretty easy to measure the uranium, but Patterson was really struggling to measure the age of the lead. And he basically tried everything he could do to figure out why this lead was so difficult. And he eventually realized that there was lead everywhere. And this is, going back decades and decades. And so he eventually did measure the age of the Earth almost exactly to the value we use today, about 4.5 billion years. Then he spent the rest of his career taking this discovery that there's lead everywhere and making it a public health issue. And this is back when we had lead in paint and lead in light bulbs and lead in gasoline. And it was causing massive problems in the health of children and the health of the elderly and really the health of everybody. And of course today there's no lead paint. You buy or rent a house, you have to sign all these forms saying there's no lead paint in there. Every time you fill up your car it says unleaded gasoline. And this is really all due to the efforts of Patterson and scientists like him that showed these levels of lead were dangerous, they were unnatural. And they did so in the face of tremendous industry pressure, often from the petroleum industry. And so in a way, this was kind of an allegorical story to today's struggles with climate change. Again, we sort of, in doing other things, we accidentally discovered how dangerous things like carbon dioxide are to the environment of our planet, and yet the tremendous economic interests that certain industries have about these processes make it challenging and painful and a long struggle to really overcome them for what will eventually be a marvelous public health benefit.
David, how did you like it?
I thought it was pretty good. I mean, it mirrors a lot of those. This was one again that when I started watching it, I was like, I'd heard a little bit about the story about with going toward unleaded gasoline and removing lead from products, but I didn't quite know where they were going. I wasn't that familiar with it, so I was it kept me engaged trying to see where they were going with it. I mean, and it mirrors a lot of the battles that science has had with industry, like you think about to remove ozone-depleting products in the 20th century. That was another big battle that was similar to the battle with health and big tobacco and things like that. And it does show those kind of sides. I thought that was interesting that they really told an unknown but important story of the 20th century science.
I got to catch up, but I mean, just in my experience so far, Cosmos has been getting better and better every single week. Each week, I'm like, that was great, and yet
I always hate to say,
which seems like backwards.
This was the best episode ever, but
yeah, and then at the same time, it feels like the stories they're telling are really interesting, and yet I'm a little, not concerned. I think it's the right move to do, is that they're not the mainstream stories that a lot of people are aware of, that people have heard 1,000 times. Like, they're picking really interesting examples of telling some of these scientific stories that are not necessarily the big ones that we've all heard about, Galileo finding the Jovian planets and then getting himself in trouble with the church and so on and so forth, right? And Tycho Brahe and all these, Copernicus and so on. Like, they're picking some of these more obscure stories and they're telling them really well and they're showing examples. So they're doing a great job. It's too bad that the ratings aren't matching the quality of the show that they're producing, but I suspect that they'll sell a zillion of them.
The ratings aren't bad though. They're holding up pretty well. I think they got whacked by the launch of Game of Thrones.
That's right.
And so I think probably never again will the ratings be as high as they were before that. But I think that I don't think they're disappointed by the audience that they have. And
I think
that's good news.
Cosmos is doing a great job with keeping to the core holistic mentality of what Carl Sagan was originally doing. I mean, we have to remember that Cosmos, I mean, this is Sagan's show, and his inspiration and his wife's writing it, and I mean, they're carrying on basically what he would have done, and it is true. His outlook on science was very holistic. It's not just about what's happening in the universe. To study the universe is to study what's happening here on Earth. Is to study what's happening inside our bodies and inside a star. I mean, it's all the same thing. And I think that the show's doing a really good job with connecting things, and that's what it's all about. It's making a connection between everything.
Yeah. All right. So, Jason, I think we've got time for just one last little update on the Laddie impact.
Yes. Well, as you may or may not have heard, NASA's Laddie mission did impact the moon. I want to say it was last Friday. Now, correct me if I'm wrong.
It happened just before when we were recording last Friday.
It was after the eclipse, yeah.
And
you just can only think in terms of eclipses.
Laddie did manage to snag a couple of images right before it hit the moon's surface, and what it saw was the zodiacal light. It saw some, which is some of the light that's reflected off of the small dust particles that are existing in the ecliptic plane. So, as the sun's light was behind the mountains of the moon, it did pick up some of that glow from the zodiacal light, but it didn't see the streamers of light that, or I should say the it is kind of like a streaming glow, like you would see from the sun at sunset or something. That Gene Cernan saw when he was looking at the lunar horizon. So unfortunately, the Apollo mystery wasn't really picked up by Laddie, but it's still preliminary, and they still have to go through some of the data that was picked up by that was acquired by Laddie before it impacted the moon's surface. But if you want to see the images, and there's even a little bit of an animation that was put together, go to Universe Today, and Bob King had put that together and posted it. I want to say just earlier today. So it's really fascinating to watch, and I think these are some of the first. Now I don't know if these images are color images or if Bob colored them. You have
I'm not
to,
sure. Yeah.
Yeah, but they're really interesting. So go check those out.
Yeah.
You can see the light, basically the light of our solar system. Behind the moon, and it kind of reminds me of some of the images I'd seen from the Clementine mission back in the 90s, where that zodiacal light was picked up there as well.
The early Surveyor missions had picked up a glow from the lunar surface as well, a mystery glow that was similar to what the Apollo astronauts saw. So
basically, what that light was from, or is believed to be from, is lunar dust that's kind of suspended in the moon's exosphere, a very, very, very thin atmosphere, and kind of hangs there through its own static connection, because the lunar dust is very, very fine, and that's really one of the things that Laddie was looking for. So unfortunately, these pictures don't show it, but the data may still be there. It just needs to get teased out.
We've never had a human on the surface of the moon witness a sunrise yet. In orbit, they have, but.
Yeah, I always love the way NASA describes. They had like they say they had like a successful landing.
Laddie.
Hard landing.
A successful mission end. Yeah.
Mm-hmm.
Yeah, we smashed it into the moon. Good. All right, cool. Well, let's wrap this up then. Brian Coberline, where do we find out more about what you're working on?
You can find me on Google+. You can find me on my website, One Universe at a Time, which is briancoberline.com, and on Twitter at Brian Coberline.
Fantastic. Dave Dickinson, where have you been?
I am AstroGuys with a Z. I'm on my own platform, www.astroguys.com, and I'm active this week on Canada.com, Universe Today, and Listosaur.
Jason Major.
I am at lightsinthedark.com. I also write lovely articles for Universe Today, some very interesting articles for Discovery News Space, and I'm on Twitter at JP Major.
Morgan.
Yep, I'll be taking your questions right after this over at the Google Plus Space community. If you just go to Google Plus, go to Communities, find Space, and join us with anything we weren't able to talk about today, or anything that we did talk about and you want to talk about it some more. You can find me at cosmicchatter.org, and we're on Twitter at cosmic_chatter.
Awesome. All right. Well, and so just one last reminder that we're going to be doing the 36-hour, who thought of that? 36-hour Hangout-a-thon. Starting at 8 o'clock Pacific tomorrow. You're going to find it at CosmoQuest. You'll find it on Google+. We will link to it from Universe Today. We will tweet it. There will be all kinds of hashtags all day long, so starting in less than 24 hours. So we'll see you all tomorrow, and then you'll see all of us for 36 straight hours, or some of us. So thanks, everyone, for watching. We really appreciate it. Really appreciate your support. And as Morgan said, if you want to continue the conversation, head over to the space community and fire only the hardest questions at Morgan, and he will handle them all with grace and dignity. So thanks, everyone, for watching. We will see you all next week.
Casing projects that people are doing all over the world with astronomy and science education. We'll also be throwing in some fun, silly game aspects too. We'll have some really creative art stuff. We'll have a virtual star party. We're just going to have it all. So you can go to the CosmoQuest Google Plus page where there is a link. We're also putting out countdown tweets every hour, so you can find the donate page and the page where you can watch the Hangout. And I will give you see if I can give you a brief look. Here's the attic as it's coming together. Oh, you guys are gonna get dizzy. This isn't working.
Oh, I should have brought you my
Vertigo kicking in.
There we go. There's people and set and things and tiny intern behind me. So yeah, we are currently getting everything finalized for this big event, so we hope you can join and watch and share the link, mark craters, do all the fun stuff. We really hope you enjoy and get a kick out of it.
And everything gets going at 8 a.m. Pacific on Google Plus and on CosmoQuest, and we'll post a link on Universe today. And it's going to start at 8, and so that's 10 o'clock Central, 11 Eastern. No, yeah, 11 Eastern, and then 4 p.m. British time. So even the Australians, 1 in the morning. So
we have people from around the world joining us, and we'll be doing the social media feeds as well. So it'll be a pretty big event, and this is all to raise money to make a more scientific future for all of us.
That's awesome. Well, we're, as part of the CosmoQuest umbrella, we're glad to help out. All right, now, did you want to stick around and mention any stories, or do you want to book out?
No, there are way too many people in this room who are keeping quiet just for this, so I'm going to sign out and continue working on setup. So thanks for letting me do the plug.
All right. Can't wait. See you later, Nicole.
See you later.
All right. So stories. I forgot to mention the stories. So we're going to talk about the EVA that happened, and an update on what happened with SpaceX. Because last week we broadcast the SpaceX launch. Hey, and guess what? Guess who got a copyright takedown request? Within a day, I got a copyright violation because I was posting a stream from NASA television.
Cool. That's the lost episode now. So.
Yeah, it is. Well, no.
Who was it? Who issued
it said it said CDS Mail, MALE. So, so I think people think that CDS means for the
menswear catalog.
I don't know. No, it stands for like content. Detection service or copyright detection service or something like that. Why it said mail, I have no idea. But anyway, apparently someone out there somewhere owns
because
NASA
you're
television.
a man and you put up a streaming NASA video.
Right, of course. Yeah, that's it. So anyway,
that's weird.
Whatever you do.
We embed those launches on our websites all the time. So.
Yeah. So Google, we really appreciate you defending other people's ownership of NASA television. That's we think that's right, and as opposed to recognizing that NASA releases it license free to the universe and anyone can use it for anything they want, including bringing it into the Weekly Space Hangout. So we're gonna give a sort of an update on Cosmos, which we've all been watching except for me. We're going to talk about asteroids. Maybe are going to hit Earth more often. Maybe. Yay! It worked. Hey everyone. My name is Fraser Cain. I'm a publisher of Universe Today, and this is your Weekly Space Hangout for Friday, April 25th, 2014. And joining us this week, we've got Brian Coberline.
Hi.
We got David Dickinson. Hey, David.
Hey. It's crappy internet, as always.
As always. Got Jason Major.
Hey, not much better internet here. Yeah.
We got Morgan Renberg. Hey, Morgan.
Hey, Fraser.
And Nicole. Dr. Nicole Gallucci, also known as Hangoutathon.
Hi everyone, I am here to do a brief plug for the Hangoutathon that is starting in 20-something hours, I think 20 hours from now. I'm in Pamela's attic, right now. We are setting up the schedule, the set, the props, all the fun things. That's why I'm wearing these silly things. They supposedly respond to brainwave activity, and so we're gonna hopefully be including these soon in our guerrilla science outreach efforts, so we can have people wearing funny ears and seeing what they do while they're mapping craters.
So just over the course of the Hangoutathon, as they start to droop down.
Exactly, they're just gonna be like
the brain activity approaches zero. Okay, so what is the Hangoutathon, Nicole? So people don't know what's going on. What's the I almost called you Pamela.
I know!
You're a distinct person from Pamela. I know it.
Nobody's done that in a while. Jeez.
No, I know.
So the Hangout-a-thon is a fundraiser event. It's actually kicking off a 36-day fundraiser that we're doing for CosmoQuest. We're starting with a 36-hour-long Google Hangout on air. We will be celebrating science education. We'll be showcasing.
Maybe not going to hit Earth more often. We're going to have a bit of a fight going on.
More often. That's a relative term. So.
But devastating asteroids cripple the planet on a regular basis, or not ever. So somewhere in between. And we're going to talk to, we're going to have some interesting observational stuff. So let's get cracking. Morgan, why don't we start with the sort of the things that happened in human spaceflight over the this last week.
Yeah, so going back maybe about a week and a half now, there was routine testing of computer systems on the International Space Station. And they do this every once in a while just to make sure that everything's working all right. And this last test revealed that one of the computers, a backup computer, called an MDM, was malfunctioning. And an MDM stands for a multiplexer and demultiplexer. And this is basically a technique of taking a bunch of communication signals, and combining them into one very efficient signal to send back to the Earth. And you can imagine this is important for communicating all the data back and forth to the space station from hundreds of miles above the surface. Unfortunately, this is the only computer on the space station that isn't in the space station. It was bolted to the outside of the space station. And so they did some tests. They determined that they couldn't just let this thing sit there broken. And they sent out astronauts, basically, to go out earlier this week on Tuesday and fix this computer, replace it with a backup that they had stored on board. And normally this would be no big deal. But you might remember that over the last year or so, NASA's had a number of issues with spacewalks and spacesuits, from filling up with water in the helmets to getting heating problems with some of the external heaters. And so they'd actually basically sworn off of spacewalks that weren't for emergencies. And so they had to classify this basically as an emergency, and they sent out a pair of American astronauts to replace this earlier this week, and it went off completely without a hitch. It was, in fact, the shortest successful spaceflight in the history of the International Space Station. I'm sorry, spacewalk in this history of the ISS, at just over an hour and a half. And they went out there, they took off the old computer, they bolted on the new computer, and got back in, no problems. And this included the use of a brand new spacesuit that had just been flown up, last Friday, a week ago today, on the new Dragon capsule. And so they were able to put that into service and use one of the other spacesuits that they thought was working well, and they had no problems at all.
That's amazing that they used one of the new spacesuits and put into a spacewalk right away.
Yeah, so they included all of those safety mechanisms that they'd been developing over the last year, like the straw snorkel and the water-absorbent pads and all of that stuff. So that was all included just in case. But as far as NASA has made publicly available, none of the astronauts encountered any unusual problems with their equipment while working on this.
That's amazing. And so what happened with the SpaceX launch? Now, as I mentioned, we, of course, got in trouble with international copyright law by broadcasting the launch. What happened?
Yeah, so it basically went off without a hitch. So the launch happened, it boosted the Dragon up to the space station, and that docked, normally as expected. And then what was new this time is that they bolted landing legs onto the Falcon 9, the actual rocket that launches the Dragon. And as it fell back to Earth, they extended these legs and restarted the engine. And they used this engine basically to safely power the rocket back down to Earth, rather than just letting it plunk down into the ocean. And so they were able to controlled fly the rocket back to the surface of the ocean, where it hovered for 8 seconds before it was taken out by a wave.